Greetings and salutation. We are from Group 1. We present about our group project, which is Piping and Instrumentation Diagram. Start my presentation by introduction for this group project. The Piping and Instrumentation Diagram (P&ID) is a crucial instrument employed across multiple industries with a particular emphasis on engineering, manufacturing, and process-oriented sector. The diagram offers a graphical depiction of the complex interconnections among various components such as piping, equipment, and instrumentation within a given system or process. A process and instrumentation diagram usually represents the relationship among various elements, including pump, valves, vessel, control system, and the movement of fluid, gases, and other substances. Now, there are 6 objectives of why we should use P&ID in our power plant. Firstly is system understanding. Secondly is communication and collaboration. The third one is assessment of safety and risk. P&ID draws attention to crucial safety elements like relief valve, emergency shut-off valve, and alarm, enabling staff to see possible risks and take the necessary precaution. P&ID are also useful for building emergency response plan, identifying crucial control point, and performing risk assessment. And the fourth one is engineering and design. P&ID serve as the basis for a project engineering and design stages. They provide the data required for choosing control techniques, defining instrument, deciding on pipe routing, and sizing equipment. And the fifth one is operation and maintenance. P&ID aids in organizing maintenance tasks, locating spare components, and carrying out system alterations or upgrades. And the last one is compliance with regulation. P&ID helps to show that certain regulation and industry standards are being allowed for law. They record important elements including process parameters, environmental controls, and safety features. That is all. I will pass the presentation to my group members.
In this process description, we will briefly describe the whole process of transferring fluid from VE201 all the way to T209. VE stands for vessel and T10 stands for tank as its final destination. The process starts after the initial pressure, temperature, level of VE201 and VE202 was checked and its line tracing was completed. Then all manual valves and actuators valves were opened along the pipeline from VE201 to VE202. Before the fluid from 201 to VE202, it undergoes esterification process when the palm oil was converted into fatty acid alkyl esters, or also known as FAAE, which are the main components of biodiesel. After that, the FAAE from the VE202 was then transferred to VE203, where the fluid will be heated and undergo polishing by using chemicals. The procedures are the same as transferring from VE201 to VE202. Last but not least, the final product, which is the biodiesel, will be transferred into the tank T209 to be stored. The process procedures are also the same as the previous ones. That is all for process description.
For equipment and line, for process in T209, we have vessel VE203 as a container to hold or transfer palm oil or carrying out chemical reaction. We have valves including butterfly valve, actuator valve, bow valve, and check valve control or regulate the flow of palm oil, and there is a bow valve using as bypass. We have wide strainer STP203A, which is a filtration device to remove solid particles from palm oil. Pumps such as side channel pump and centrifugal pump to transfer palm oil by increasing pressure. Have furnace to heat palm oil. Heater to separate palm oil to another place. Heat exchanger to cooling or heating palm oil. And lastly, the line in T209 is a product line, which is the flow path of palm oil.
So this is the first P&ID diagram, and the second P&ID diagram is extracted from the actual P&ID diagram of plant biodiesel UTHM. Greeting and salutation, I'm Dashwinan. Today I'm going to explain about the P&ID diagram which is with symbol legends, and I will compile tracing line, equipment, and the flow process. So I will start with the colors and lines. So we can see that we have four different color: orange, blue, gray, and green. So the orange stand for the steam line, which is transfer from the boiler house to the plant. So it will divided into 4-bar steam line and 2-bar steam line, depends on requirement of the process. So VE201 and VE202 is involved in process of preheating, where the steam line will transfer into the vessel for the preheating process. So VE201 and VE202 almost identical but not same, not equal, where the VE201 require 2-bar steam while VE202 require 4-bar steam. So the steam line have bypass, which required during the maintenance. The bypass will involve during maintenance of control valve or temperature valve at VE201. So the VE201 involve feedback control loop system, where the control valve will controlled by the temperature indicator and temperature level from indication from the VE201. So when it's require more temperature, the control valve will open more. When it's require low temperature, the control valve open less. So the same feedback control system used in VE202 diagram, which is extracted from PID 003, which involve VE203 and T209, which involving in polishing. So the product from VE202 will transfer pump or pump in inside VE203 using pump 202, and here also same, the VE202 using 4-bar steam line and to heat up the CPO during polishing, and also the CPO F bypass and using feedback control system for temperature control valve, and the cooling water from the cooling tower interconnected with the condensate line, and also the condensate line F bypass and the drain. So we have another addition equipment here is the heat exchanger. So the product from the VE203, after heating at the certain set point, it will transfer by the pump. We have two bypass pump, identical bypass pump, which is one will be operated, which is P203A operated mainly, and if it in maintenance, the P203B will operate. So it will pump the CPO into the heat exchanger, while the heat exchanger line will pump the cooling water from the cooling tower. So we have another control loop system, feedback control loop system over here, which the temperature indicator of the outlet from the heat exchanger will indicate the temperature and send the signal to the control valve, which connected to the flow of the.
For the safety part, safety precautions are essential when operating in a plant. First, we should follow the standard operating procedure. Then we should wear personal protective equipment such as safety helmet, safety boots, and safety coverall and gloves. Good communication between utility, plants, and control room is needed to facilitate timely response to emergency, enable information sharing, and coordinate to minimizing the chance of accident or failures. Then make sure all the manual and automatic valve is open when receive palm oil from other place to T209 or transfer palm oil from T209 to other place. Make sure all the equipment and valve are in good functioning. Label hazardous material properly, provide safety data sheets for all chemicals, and educate operators about the potential risks associated with each substance. Regular safety inspection and maintenance is needed. And lastly, keep work area clean, organized and free from clutter. Properly store tools, chemical, and equipment to prevent tripping hazard and facilitate emergency response.
Okay, now I'm gonna talk about the control loops based on two P&ID diagram that we have, which discuss the reaction process and the polishing process, which involve a vessel of VE201 to 202 and VE203 to T209. First, I'm going to talk about a control loop inside VE201, which involves a feedback loop. These loops control the temperature of the vessel by using temperature element TE201 and temperature indicator controller, which TIC201. This temperature controller then signal the temperature to the temperature valve TV201 to regulate the flow rate of steam entering the vessel, thus control the temperature inside the vessel. When the temperature reaches certain amount or the set point, the control system either lower the flow rate or cut off the system from the control room entirely. Next is the VE202. VE202 also uses a feedback loop, which control the temperature of the vessel by utilizing the temperature element TE202 and the temperature indicator controller TIC202. Then it transmits the electrical signal to the temperature control valve TV202, where the flow rate of the steam will also be regulated according to the set point intended. VE202 also have a temperature indicator 202 at the plant, where the antennas at the plant can monitor the temperature from the plant and compare it to the temperature from the computer inside the control room. Next, we also look at VE203, where also using a feedback loop that controls both temperature and pressure of the vessel. Then vessel 203 control the temperature of the vessel by using a temperature element 203 and temperature indicator controller TIC203. Then the signal transferred to the temperature valve to regulate the flow rate of the steam entering the vessel, thus control the temperature inside the vessel. The pressure, however, controlled by pressure valve and pressure indicator, and monitor by control room by receiving the signal from the pressure transmitter and pressure indicator controller, and the control room will notify the crew inside the plant to open the valve, pressure relief valve, if the pressure is close or reaches the set point. And lastly, we talk about T201 vessel. T201 control the level of the biodiesel inside the tank. There are two level indicators attached to the vessel, which was the level alarm high and the level alarm low. When the vessel is at low level, the indicator will transmit an electrical signal to control room, and the indicator inside the room will translate into green color in the computer. When the temperature is at very low level, the indicator will change color into red. When the level reaches almost at the maximum capacity, the color of the indicator will turn green, meaning that the level of the biodiesel is almost at full tank. That's all. Thank you.